Venus looks calm from a distance. A bright, steady point of light in the sky. Smooth, golden, almost peaceful. But that appearance is completely deceptive. Because beneath those clouds, Venus is the most hostile world in the solar system. Closer to Earth than any other planet. Almost the same size. Often called Earth's sister. And yet in reality, it is a world where nothing we know could survive. To understand Venus, we need to start with one simple fact. Its atmosphere is not like Earth's. It is almost entirely carbon dioxide. Over 96%. The rest is mostly nitrogen. There is no oxygen to breathe. No water vapor in any meaningful amount. And floating within those thick clouds are droplets of sulfuric acid. Not just traces. Full layers of corrosive acid clouds circling the planet. Now imagine standing on the surface. You wouldn't see the sky. You wouldn't see the sun clearly. The atmosphere is so dense that light is scattered in every direction. The sky would appear yellowish, dim, and hazy. But the real danger isn't what you see. It's what you feel. Because Venus is incredibly hot. Hotter than Mercury. Even though Mercury is closer to the Sun. The surface temperature on Venus averages around 465 degrees Celsius. That is hot enough to melt lead. Hot enough to destroy most metals over time. This extreme heat comes from something called the greenhouse effect. On Earth, greenhouse gases trap some heat. On Venus, that process has gone out of control. The thick carbon dioxide atmosphere traps heat so efficiently that once energy enters, it cannot escape. The result is a permanent heat trap. A runaway greenhouse effect. And once that process started, it never stopped. Now consider pressure. On Earth, at sea level, we live under one atmosphere of pressure. On Venus, the surface pressure is about 92 times higher. That's equivalent to being nearly 1 kilometer underwater on Earth. If you were somehow placed on Venus, the pressure alone would crush you instantly. Now combine that pressure with extreme heat and a toxic atmosphere. And you begin to understand the environment. But it gets even more extreme. Venus rotates very slowly. A single day on Venus takes longer than a year. It takes about 243 Earth days to complete one rotation, but it orbits the Sun in about 225 Earth days. That means a Venusian day is longer than its year. And there's another strange detail. Venus rotates in the opposite direction to most planets. If you stood on Venus, the Sun would rise in the west and set in the east. Now look at the surface itself. Venus is covered in volcanic plains. Large, smooth regions formed by ancient lava flows. There are thousands of volcanoes, some of them hundreds of kilometers wide. Evidence suggests that Venus may still be volcanically active today. But we don't know for certain, because observing the surface directly is extremely difficult. The thick cloud cover blocks visible light, so scientists use radar to map the surface, sending signals through the atmosphere and measuring how they bounce back. This is how we know what Venus looks like below the clouds. Now consider exploration. Several spacecraft have attempted to land on Venus, most notably the Soviet Venera missions. These were some of the toughest machines ever built, designed specifically to survive Venus. And even then, they lasted only minutes. The longest surviving lander operated for about 2 hours before the heat and pressure destroyed it. Electronics failed, materials degraded, systems shut down. Because on Venus, everything is constantly being pushed to its limits. Now think about water. There is almost none on Venus today. But scientists believe that billions of years ago, Venus may have had oceans, liquid water, conditions that might have been similar to early Earth. So what happened? The leading theory is that as the sun's energy increased, more water evaporated into the atmosphere. Water vapor is a greenhouse gas. So this increased the heating. More heat caused more evaporation, and the cycle continued. Eventually, the oceans disappeared. Water molecules were broken apart in the upper atmosphere. Hydrogen escaped into space. Oxygen reacted with surface materials, and Venus lost its water permanently. What remained was a dense, dry, carbon dioxide atmosphere, trapping heat, raising temperatures, and transforming the planet into what we see today. Now consider the wind. At the surface, wind speeds are relatively low because the atmosphere is so dense. But higher up, in the cloud layers, winds reach incredible speeds, over 300 kilometers per hour. These winds circle the planet in just a few days, a process known as superrotation, where the atmosphere moves faster than the planet itself. Now step back. Look at Venus as a system. Extreme heat, crushing pressure, toxic atmosphere, acid clouds, volcanic landscape. Every element works against survival. Every condition pushes toward destruction. And yet, this planet may hold answers. Because Venus shows us what can happen when planetary systems change. When feedback loops spiral out of control. When balance is lost. It is not just a distant world. It is a case study, a warning, a natural experiment on a global scale. Understanding Venus helps scientists understand climate systems, atmospheric dynamics, planetary evolution, and even the future of Earth. Because while Earth and Venus are very different today, they started out with similarities, and small changes over long periods of time can lead to completely different outcomes. Venus is not just hostile. It is extreme in every measurable way. A planet where physics dominates completely, where chemistry reshapes the environment, where conditions exceed the limits of human survival. And that is why Venus stands out, not just as a neighboring planet, but as the closest thing to hell in our solar system. If you enjoyed this deep dive into the forces shaping our future, be sure to explore our other documentaries examining the technologies redefining modern civilization. And if you want to keep exploring the biggest questions about science, power, and the future of humanity, make sure to subscribe to the channel and join us for the next journey into the unknown.